built a 18650 battery wall, DIY. It's made up with these cells. These are salvage cells from power tools and laptops and things like that. The configuration here is a 7 in series, and then there's 29 batteries in parallel, and this is a second battery made the same way. So we've got 420 batteries made up, but I have a solar inverter, 24 volt solar inverter, and before I wanted to install it full time, I thought it's best to do some tests. So I've got some multimeters here. I've got a MTi multimeter, and currently the batteries are 26.54 volts. Being 7, they should be up to 28 volts. So that's the idea. And I've got a current clamp here, also a MTi current clamp, and they're busy charging at about 3.8 volts. So that's quite important. But what I really wanted to find out was, is there any hot spots on the battery bank, batteries failing or things like that? So I'm using a thermal imager, and basically I'm just running it over the battery cells to see. Now it all looks actually quite good. What you will notice is where the wires are, these big copper wires that are running on, those are slightly warmer. I don't know if it actually shows on the, there we go, there you can see a little bit of a warm spot there, but those are really not very hot at all. You can see if there were any hot spots, they would pick up quite nicely. So I've done a very simple test set here, and you can see by using this thermal imager, you can see how that connection is not a great connection, and it's actually quite warm, whereas the secondary connection on the negative is not as warm. So as I said to you, this is just a test rig, just to test the batteries, but I've got all my equipment here working, giving me all the information I need. So I'm really quite impressed with this thermal imager, identifying just these tracks that are getting a bit warm, but that's understandable. We're moving 3 amps through the battery cells, but otherwise I'm very impressed. To give you an idea how a thermal imager works, I'm going to show you a kettle. You can see at the top, the lid is quite warm, and you can see through the glass. It's not easy to show you, but it's showing 34. There we go, that's much better. Okay, so through the glass, it's showing the water temperature is 36.6 degrees, but everything else, you can see the countertop around it, 20 degrees, back on the water. It displays it really nicely with a heat map, so it's easy to see if there's faults. The reason I was using it on the batteries is if there was hot spots where batteries were charging at a abnormally high rate, or they were short-circuiting, those would pick up hot spots there. Okay, so I'm just checking up now. Things have remained nice and cool. Even you can see the copper line. Still very evenly heated, 23 degrees odd. No abnormal hot spots that we're seeing. So that's really nice to see. Got multimeter going. Voltage is climbing a little bit. It's still quite overcast, but yeah, that's still good from a current point of view. So it's 0.7 of an amp, 0.5. It's not drawing very much at the moment. Current's fluctuating with the amount of sunlight hitting those panels, but all in all, still quite good. This is a MTi 2 RMS multimeter. It's the MT1003, and we're going to put it on voltage DC. She's got a really nice, bright, clear color screen. And very responsive display. We're measuring 26.88 volts. I've adapted some other test leads onto it, but it comes standard with a decent set of test leads. Really nice clear display. Over here I've got the Magitech 777. It's a current clamp, so I'm going to select current, which is DC current here. I'm measuring on the DC battery side, and I'm going to just select DC amps, and you can see responsive, also color screen, 0.6 amps. Really nice and easy to see, clear display. It's also got Bluetooth. You can get an app on your phone if you want the details on your phone as well. Nice, easy to use, got a decent size clamp. It's got options for range and for lock. You can hold your reading if you need to. It's got min and max values that you can use. You'll see the current is fluctuating. This is connected to a solar inverter system, so depending on the amount of sun that's coming in is how much current is being fed through to the battery.